Okay, cool. So 2 plus sec theta is equal to 0. So I have 2 plus sec theta is equal to 0. Now, I don't have sec on my calculator. I have sine, cosine, and tan. So I'll have to use some of the identities to change sec into one of the operations or one of the identities on my calculator. So if I go back up, I see that our sec has a relationship with cosine. So sec theta is 1 over cosine theta. So I recall that sec theta is equal to 1 over cosine theta. So I'll have 2 plus 1 over cosine theta is equal to 0. 1 over cosine theta is equal to -2. And I have a couple of things we can do here. And this might be a new skill. I can invert both sides. So if I invert both sides or I flip both sides, I get cosine theta is -1/2. Well, the first thing I notice here, cosine is negative. So when cosine is negative, where are my solutions? My solutions will be here and here. I'll always have to calculate my principal value, which will in this case be cosine inverse the modulus of -1/2, which will be cosine inverse of 1/2, which will be 60 degrees. Theta is in my second quadrant and my third quadrant. So theta is equal to 180 degrees. Take away the principal value, which is 180 degrees. Take away 60, which is 120 degrees. And theta is 180 degrees plus the principal value, which is 180 degrees plus 60 degrees, which is 240 degrees. Now you can go and work out the rest of solutions. Just keep working until you go out of the domain, which ends at 870 degrees. So just keep working on and on and on. So let me do number 6. Tan theta into cosec theta plus 2 is equal to 0. A number of ways I can do this. Now, the first thing you'll probably gravitate to, which is by all means correct, is put the substitutions for tan theta and put in the substitution for cosec theta, which is all well and fine. So let's do it that way first, and then we'll do it the easier way. So first, I'll recall. Now, if I just replace cosec theta with 1 over sine theta, I still have two different identities in my question. In trigonometric equations, for now, the aim is to get one identity in the question, either it's all sines, all cosines, or all tans. So if I just replace cosec, I still have a tan and I have sines. I will replace tan as well to get rid of the sines and have one identity in the question. So tan theta is sine theta over cosine theta, and cosec theta is equal to 1 over sine theta. So I end up with sine theta over cosine theta, open bracket, 1 over sine theta plus 2 is equal to 0. Well, when we expand this out here, I'll get sine theta over cosine theta multiplied by 1 over sine theta plus sine theta over cosine theta multiplied by 2 is equal to 0. You cancel with you, and I get 1 over cosine theta plus sine theta over, well, 2 sine theta over cosine theta is equal to 0. Same denominator, 1 plus 2 sine theta over cosine theta is equal to 0. I can hit a little cross multiplication here. 1 plus 2 sine theta is equal to 0. And 2 sine theta is equal to -1. Sine theta is -1 over 2. I can go and calculate the values of theta just like I did before. Or An easier way, and I will say it's a more effective way because you get more solutions. If we recall the skills involved in quadratics, if I have x minus a into x minus b is equal to 0, I solved x minus a is 0 and x is equal to a, or x minus b is 0 and x is equal to b. This was a skill from quadratics. I actually have something resembling an x minus a and an x minus b up here. I have tan theta into cosec theta plus 2 is equal to 0. This looking like my x minus b, and if I had put tan theta minus 0, I will get something looking like a x minus a. And I'll perform the same operation. I'll have tan theta could be 0, and I solve for the values of theta. Using my quadrants, I solve for the values of theta, and I have cosec theta plus 2 is equal to 0. I'll recall my substitutions. I'll get 1 over sine theta is equal to minus 2. Flip both sides, and I get sine theta is equal to minus a half. Now, tan theta is equal to 0. Theta will always be equal to 0. That will be the solution for here. Theta will be equal to 0, and no other answer, just 0. It'll always be 0. All right, but sine theta is equal to minus a half. If you realize, I get back that answer there. But when sine theta is minus a half, and I use this purple method, I will not get the solution theta is equal to 0. I wouldn't get a solution. All right, so you just have to be very careful when you're calculating solutions to make sure you cater for all possible solutions. Now, if you do the purple way, you'll get your marks, right? Odds are you'll just lose the 1 or 2 marks for not calculating theta is equal to 0. Because by all means, when theta is 0, I end up with tan theta being 0. This whole thing is 0. If that whole thing is 0, 0 multiplied by this whole thing is going to give me 0. So those are 2 sets of solutions we can get using the green method, right? For 2 different trigonometric identities. Whereas using the purple method, I got 1 trigonometric equation and I solve it, right? So you can go ahead and try to solve these 2. And in the next video, we will dive into quadratics and the tricks.